So here we are with our last lesson in our book, Integers 3. We're on page 16. We're taking notes. So on top of this page, oh, I don't have my, hang on a minute. On top of this page, I want you to write notes. If my pen is working. Okay, let's look at, by the way, does anybody know what integers means? What does that word mean, integer? Can you give me an example of integers, Sarah?
They're like the negative and plus signs that we use to help us count in a problem.
Yeah, so that's a good explanation, the negative. And are those integers fractions or decimals, or are they whole numbers? Have we dealt with fractions or decimals in these lessons, or was it always whole numbers?
Whole numbers.
Yeah, so they're whole numbers. And sometimes in math, we kind of start this. When we explain something, we go dot, dot, dot. And I want somebody to tell me, what do you think this means if I put dot, 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 and then I'm going to list some numbers, and then I go dot, dot, dot again. What does that mean, do you think?
It means it keeps going.
The numbers keep going on.
Yep, keep going on in this direction and in this direction. So this is a good representations of integers. So this is, I'm sometimes thinking, make sure you understand what the words mean, right? So let's look. A fish is swimming 15 feet below sea level. So if you think of sea level, and this is my ocean right here that I'm drawing, sea level is the 0, but the number line is actually a vertical number line, because when you go dive into the ocean, right, you're going down, not sideways, you're going up and down. So sea level is 0. And then we have the negative numbers below sea level, and we have the positive numbers above sea level. Okay, does anybody know what level we are here in Pine Valley? What's our elevation?
4,000.
4,000 feet above sea level means we are at a plus 4,000. Now, if you go to the ocean and you dive under the water, you're going into a negative number because you're below sea level. Hang on, somebody else is joining. This is, okay. Is it Ruby I call you, Perla? Because I don't remember exactly what, it's Ruby, right?
Yeah.
Good. Oh, thank you. I was like, huh? I forgot. I know you don't. Anyways, we're looking at our textbook and we're on page 16 right now. So go ahead and go there. So anyways, let's look at the fish is swimming 15 feet below sea level. So what number would that be? So that would be negative 15 because it's down under the water, negative 15 feet. If 0 represents sea level, what number represents the fish elevation? Well, we just said it's below sea level, so it's a negative number. Yeah, so under, going down, negative. A dolphin is swimming 3 times as deep as the fish. 3 times means it's multiplication, right? 3 times as deep as this. What numerical expression represents the elevation that is 3 times the depth of the fish? Well, it's 3 times negative 15. Now, the way we write that is with parentheses. So between 3 and the parentheses, there's no symbol. That means it's a multiplication. that is not even there, but it is understood to be multiplication. So that's how we write 3 times. I'm going to erase that little dot. Okay, what number represents the elevation of the dolphin? Now, who can tell me what that is? 3 times negative 15. Aiden, do you have any idea?
Or negative 45.
Good job. Negative 45 feet. So the dolphin is 45 feet under the water, under the sea level, okay? So remember, this is all vertical number lines. A thermometer, oh, this is my vertical line, very, very crooked. Okay, during a cold week in Wisconsin, but almost like here now, the temperature each day at noon in Fahrenheit was 4 degrees, -6, -1, 3, and 0. So a number line can be a thermometer. So we have 0 degrees, and our positive numbers are above, and our negative numbers are below 0. Okay. What numerical expression can be used to find the average noontime temperature for the week? So average, how would you find the average? Let's say, let me give you another example. Let's say Sarah had the following test scores during her math semester this semester, and I'm just making up numbers. Sarah, don't think I'm picking on you. I'm just coming up with some numbers. Those are her test scores in percent. Now, how would you find the average? Ben, what do you think? How would you find the average of her test scores? Ruby, how would you find the average of her test scores? Oops, that was a snow avalanche on my roof. Who knows how to find the average? Any volunteers?
Do you add them all up and then divide them?
Say it again. You add them and then do what? You add them and then what?
Divide them.
By what?
Oh, the number of how many numbers there are, so 3.
Yes, 3, right? So you add them and divide your answer by 3. Okay, very good. That's test scores. Now we have temperatures. We want to find the average temperature. So that's the same thing. We're just going to add these numbers up here and then divide by how many numbers there are. Okay, so 4 plus -6 plus -1 plus 3 plus 0. And how many numbers are there?
5.
1, 2, 3, 4, 5. Good. Now I want you guys to tell me, what is the top number? Everybody figure out just the top. 4 plus -6 plus -1 plus 3 plus 0.
4.
I have to think myself. 1, -2. Yeah. Okay, I got it. Who has the answer? 4 plus -6 plus -1 plus 3 plus 0 is how much?
Is it 0?
Yes, who said that?
Aurora.
It is 0, good. And then we divide by 5. Now, who knows what 0 divided by 5?
0.
0.
Good. What was the average temp at noon for the week? 0 degrees Fahrenheit. Okay, kind of turned out to be 0 degrees. Very cold. Does anybody know how cold it is right now here in Pine Valley?
28 degrees.
Yeah, about. So look, 0 is a lot. So 20 degrees would be on our thermometer. So if this is 0, and then maybe this is 10, and this is 20. So that's, but 0 is really cold. And then we have our negative numbers here down below. Okay, so this is how you use that thermometer. Okay, next question. Number 3. During the same cold week in Wisconsin, the temperature each day at midnight in Fahrenheit was these numbers. What numeric? By the way, this right here, what I'm circling with my cursor, is called a numeric. Can you see my cursor?
Yeah.
This is
Yes.
called a numerical expression because it's got number, numerical expression, okay? So I want you guys to tell me what would be the numerical expression for these numbers. Somebody tell me what to write.
-4 plus -6 plus -10 plus -3 plus -7.
And who was that?
That was me, Ruby.
Ruby, good job. Now, what are we dividing by, Ruby? Last thing down here. When we find the average, we add them and then we divide by, again, by
And
5.
then you divide by 5.
5, yeah? Because you have, now I want you guys to figure out the number on top. -4 plus -6 plus -10 plus -3. Okay. First person gets it, you can shout it out.
It's +10 for 4 plus 6, and then you just +10 plus
Okay, that's a good mistake you just made. It's a good mistake because you were using the rule for multiplying or dividing. When you have two negatives, when you multiply or divide, absolutely it becomes a positive. But now we have to check because we're really adding the numbers. So the rule for adding is different. We add -4 counters plus -6 counters. How many negative counters do we have?
The answer is -30.
-30.
Yeah, so
Yeah,
that's
it's
correct.
negative.
The answer is -30. I just want to make sure that that gets addressed, that this is not positive because we're adding all these negatives. So your answers will stay negative. So the rule changes when you add or subtract. And that's something super important we have to realize. -30 divided by 5 is how, now we're dividing. Now the rule changes again. We're having one negative divided by a positive. Our answer is -6 degrees Fahrenheit. Okay. The water level in a lake rose 5 inches per month for 3 months and then dropped 7 inches per month for 4 months. What numerical expression can be used to describe the elevation change? So that's another vertical thing, the elevation of the water level is also a vertical number line. We can say this is our normal water level, but now it rises 5 inches per month for 3 months. So what shall we write? 5 the first month, plus 5 the second month, plus 5 the third month. 3 months. It's going up. So if it goes up, it's a positive. If it drops, it's a negative. Yeah, going up, going down. And then dropped 7 inches per month for 4 months. So we got to subtract the 7 inches for 4 months. What numerical expression can be used? Okay, but we don't need to write this long line here. Who tell me how to write it shorter using multiplication? How can we
You
write?
could
do? Go ahead.
5 to the power of 3 and 7 to the power of 4.
5 plus 5 is not 5 to the power of 3. That's a good mistake because we learned from our mistake. So what's 5 to the power of 3? When we learned that, we remember it was 5 times 5 times 5. Do you see the difference? 5 plus 5 plus 5 is not the same as 5 times 5 times 5. Do you see the difference?
Yeah.
Okay, so when we add, it's not a power. A power is a repeated multiplication. Good idea, because we want to address mistakes. So who else has an idea? How can we show this shorter? Anybody? How can we say 5 plus 5 plus 5 shorter? Repeated addition is the same as multiplying. 5 plus 5 plus 5 is the same as 3 times 5. Plus, yeah. And now what? How many 7s do we have? How many negative 7s? 4 of them, right? So multiplication is the same as the repeated addition or subtraction. So this would be a better, shorter representation. Okay. After 7 months, what was the water level of the lake? Oh, after 7 months, was the water level of the lake higher or lower than the starting level? So we need to figure out what this number is. So let's do order of operations. What do we do first?
Well, I think the answer is negative 13.
Okay, well, what do we do first? Do we add or do we multiply?
We multiply.
3 times 5 plus, what's 4 times negative 7? You're probably right. Whoever just gave me that answer, I just want to do it step by step to make sure everybody understands. What's 4 times negative 7?
Negative 28.
What's 15 plus negative 28? If this is
Negative.
Yeah, go ahead. Negative 13, right? That's what you said earlier. 15 positive counters plus 28 negative counters makes 13 negative counters. This is the rule for adding and subtracting, not multiplying and dividing. So make sure you understand that. So after 7 months, was the water level higher or lower?
Lower.
Higher. Oh yeah, lower. Lower. Because it's negative. So it's down here somewhere. Lower. By how much? By 13 inches. Because now I'm looking, what are we measuring in?
Inches.
Look it up here, it tells you inches. Inches. Write this gain or loss as a number, negative 13. Okay. I think that's it for this lesson. I am sure this is all we have. So let's double check. 3.3 was notes. The review. Target practice. Nope, we can't do that because we have to be in class. So we're going to skip this. Make sure you write it above it. Then you can cross it out. And then we are skipping the poster problem. And then we're going to do this today. So this, I'll call this, let's say, let's just call it homework. But you'll work on that today, because, and then you do the vocabulary puzzle. You can work on that. And that's it. And then we have our definitions. So your book is done. You're going to have to turn that in for credit. Remember, each lesson is 10 points. Make sure you have it all filled in. So right now, I'm going to let you work on this page. If you haven't done it, page 15. So if you have not done page 15, then you will please work on that right now so we can go over the answers. I want to hear your answers. If they're not correct, don't despair, because the order of operation is not easy. So it takes a lot of practice, okay? But we do have to practice. Okay, I'm going to stop recording.